without further ado, I'd like to introduce you to Sasha Njagulj, who's Head of Sustainability at Bouygues, which is a large construction company, for those of you who are not familiar with it. And Sasha is going to talk to us today about design and delivery of sustainable buildings. Sasha's an architect, she has 10 years practical experience, and she's currently undertaking a leadership master's in sustainability at Cambridge. And she leads the sustainability hub within Bouygues, which she says is an enthusiastic team of experts at the forefront of the company's commitment to deliver true sustainability for its clients. So without further ado, Sasha.
Hello. Thank you. Okay, I hope this works. I don't mind if you interrupt me and ask questions as I go along, actually, so it makes for a more interesting presentation on both sides. So please should give okay. So first thing I need to explain normally. Yes, that's how you pronounce Bouygues. Sorry? You were great, but it's normally pronounced all sorts of ways, and my last name as well, so that's when I used to tell everybody to call me Sasha. We are, as Paul said, a very large construction company, which was founded in the 50s in France. Started with concrete buildings, and then it expanded exponentially to now include also TV stations in France, telecommunications network, civil works, facilities management companies. It's very large. In the UK, we arrived last century, and now that's where we are at the moment. I'm not sure if you can see, but here we've got Bouygues developments of property development now. We've got construction house, construction and housing. Construction meaning everything's not housing. And Thomas Vale also from Birmingham up to all the way down to southeast Portsmouth, we cover quite a large area, and from Wales to east. There is also in UK, I don't belong to this unit, but there is also facilities management and civil works. We tend to work together on projects. What is specific, I'm not quite sure how much you know about UK companies. They normally don't have very large technical departments. It's completely different for us. We have specialty in every possible discipline that's relevant for our business. So we'll have BIM specialists, we'll have structural engineers, M&E engineers, costing, everything that the building needs, or the project needs. We'll have our own specialists in-house. That's where my team also belongs. And now our role, especially sustainability, is to put together all these various expertises, especially when we review the projects for tenders. It becomes very useful. Now that's enough about Bouygues. Can anybody tell me what this is? There's a clue. Top right thing. The Earth. Yes, that's the Earth. That's where we are. And I normally, I don't think I need it for this crowd, but normally when I try to brainwash more skeptical people, I start with a full video. If you're interested, you go on YouTube and search for Carl Sagan. It's a wonderful, if you're up to poetic, philosophical speeches, it's the most wonderful description of planet Earth and where we really are, I can imagine. But I'll skip that now for time constraints as well. Why I'm putting this image is to give you a perspective. Yes, you have your daily lives, you have your issues at home and transport and at work, but really this is what we're dealing with. We need to all fit on one to dust, as Carl Sagan was saying. And everybody would have seen this, right? The three pillars of sustainability. Is anybody not familiar with this? Okay, good. However, what I don't like about this Venn diagram is that it implies that, well, this is sustainability, okay, and everything else is outside. Well, actually, you have one planet, and you have to fit all our needs within this one planet. So the concept has been further developed by Stockholm Resilience Institute to take a look at these 9 planetary boundaries, meaning how far can we push our consumption, how far can we push our impact on the planet before it actually breaks. And it actually turned out that 2 of the impacts, which I've highlighted in red, are already beyond planetary boundaries. I don't know if you've seen in the news that we're on the brink of 6th great extinction in terms of biodiversity. On the previous months was the Ice Age, so it's quite serious. I won't bore you with this, we are here to talk about energy. Just one more thing. The 9 impacts have been then further developed by Oxfam to include, so we've got the external boundaries, meaning how far we can push, but also how far we can squeeze the society before it cracks. So these are the internal limits that they've added. And I quite like this framework because it does explain quite a lot about sustainability. Now, why I'm here and why is construction company very interested? The built environment has a huge impact. I've just picked 2 of the greatest ones, and one of the left we're particularly interested in. This is not just from the operation of the building, it's also from the building of buildings, from producing of materials and things that go into that. Converted into carbon emissions, it's a huge impact. And this is 45% of all human activity. That includes transport, food, travel, anything, manufacture of any clothing that you bought, any laptops. So out of all of that, 45% is down to what I do on a daily basis. So it's quite worrying. But the good news is that if you build green, you can reduce quite a large amount of this impact. Especially what I'm interested in is, of course, the energy and CO2 emissions, but also solid waste. I mean, this part normally doesn't get translated into carbon, but actually, if you think about it, there's a lot of wasted energy in this waste. So trying to recycle as much as we can is also one of the major points. Also, green buildings can they sort of can reduce the impact, but they can also bring something to the table. So this is a report by the Green Building Council that was presented at the meeting EcoBuild. It shows, among other things, what they've done is to try to sell green buildings. One of the main problems of green buildings is that everybody says, well, they're more expensive, why would we invest in them? But actually, they rent better, they sell better, they retain their value better. So this is quite a strong economic reason to consider green buildings. Now, there are 2 keys in finishing with the sustainability in general. Okay? Going more practical, just give you two things that I consider keys to sustainable thinking, if you like. And because it's probably going to come out as a little bit of a disappointment and common sense, I've used photos of pets. So don't be nearsighted, don't be blinkered. You have to have a wider view. Okay, you have to think about everything. Sort of, how does what I'm doing here impact something else in a systemic point of view? And also, work as a team, don't work in silos. To give you a more practical example of what this really means, in UK, especially in London, it was quite popular to build buildings with biomass boilers. Maybe 10 years ago, something like that. So they were sold as quite sustainable buildings, very efficient, you're reusing waste material. So M&E engineers who designed this wonderful plant, it's going to have this wonderful and efficient building, but it didn't count on the impacts of this principle. So biomass boilers need storage in central London. It's quite expensive. It's quite difficult to find space. And moreover, it needs this mass to be brought in London on a regular basis. So you've got all the traffic impacts, all the costs of delivering this, but also the carbon emissions of all of these lorries bringing what pellets or whatever else is used to energize these buildings. So actually these wonderful sustainable buildings are not so sustainable because people in their little, limited area, just thinking about the efficiency of the building, but not about other impacts it might have. Okay. So what are sustainable buildings? First, and of course something that you will all know about is the energy performance of the building. Of course it's important. We have huge impacts in terms of how much energy the buildings use, both for living and for work. And it's really important to reduce this. But it's not just this. Again, don't think about it in a silo. It's much more complex to understand what a sustainable building really is. So you've got water, how much water is used in the building, is it recycled, is it reused? Materials. One of the things that we tend to forget, and it's only just coming out, is the embodied carbon, for example. All this carbon that goes into producing the materials that we put into buildings is going into the atmosphere now. The energy that we're going to save in the operation of the building is going to be, it's the carbon that is going to be saved later. And we need to save carbon now. So it's incredibly important to try and use low embodied carbon materials. And then, of course, responsible sourcing that goes with that and social issues. Pollution. Pick again on my biomass boilers for some reason. They've got usually quite high NOx emissions. So again, whatever you do might have an impact somewhere else. We need to think about this. Health and well-being, of course. If the building is too hot, it might not be so sustainable. You can put all the greenest materials in there. You can put all the most sophisticated systems to make it energy efficient. If it's not fit for purpose, this is not a sustainable building. And that's the end. It's not serving its main purpose, and this is to moderate the external conditions for comfort of human beings. Okay. Waste, of course, I talked a little bit about that. So this is in construction and in operation. We need to think about that. Transport, again, if the building is far away from any transport links, you will have carbon impact of everybody driving back and forth. Ecology, biodiversity. Are we knocking down a forest to build a building, or are we contaminating the brownfield? Completely different. And of course, how the whole thing is managed. You can produce, and again, thinking about working in teams, working together. This is really important to really achieve sustainable building. So altogether, this is what sustainable building is. And it can also be applied or implemented on a neighborhood level, on a city level. You have to think about everything. We have to think about everything in your life. And you have to find a balance. You can't score 100% in everything. You need to find what is the best solution for each given situation. So we quite a lot use these. These are certifications that exist in the UK. BREEAM is Building Research Establishment Environmental Assessment Method, and it's equivalent to LEED in USA. The Code Sustainable Homes, and it's on its way out. So we now have Home Quality Mark, which is a bit of a mystery at the moment. We don't know quite what's going to involve. And below I put Passive House, which is a German system, which is not strictly speaking sustainability certification. I'll explain why. So what do they do? You always have the regulatory menu. You've got your building regulations, okay? You're designing building to building regulations. If you go below that, you're in a legal territory. So you have to satisfy that. Certifications are going to push further. So you always need to do more than regulation. You have to have improvements on everything. And as the regulations move, so you'll have new Part L coming out. So you had new Part L, everybody knows what Part L is. In 2013, BRE published BREEAM 2014, which then asked us to improve on this. So every time the regulation moves, the certification moves as well. One of the issues I have with killing off the Code of Sustainable Homes is that actually what was needed was updates to the Code of Sustainable Homes to make it ahead of the regulation rather than just completely killing it off. These certifications, and any certifications, are really audits, trying to find a balance between all the categories that we looked at before. And it works very simply. So you've got all the categories lined up like that, and you can achieve a certain number of points in each category. And you know that you're not going to achieve 100%, it's nearly impossible. So what you try to do is find the right solution for your building, what you can afford to lose, what you need to achieve definitely, and get your solution, whatever it is, get to your score, whatever it is, in the most sustainable, the best way. And it will differ from project to project. One of the criticism certifications get a lot is that it's incredibly annoying. It's sort of paperwork. If any of you have anything to do with any of the certifications, you will know that this is absolutely correct. I'm a BREEAM assessor and codes assessor, and I know what it is. It's really a lot of paperwork. But as it is an audit, it is going to be a lot of paperwork. What I can tell you from practice, it does work. It really does work. I know that on the projects, for all sorts of reasons, certain things would have been lost or not done if we didn't have a certification to push through as a priority. So you would have a planning condition linked to BREEAM Excellent. We know we need to achieve 25% improvement to a part L. And we know that the building has to do this. So there's, even if the client is pushing us to cut out certain things, even if something's not working, we have to find a way to make this work. So it does work in practice. Yes, it's painful, but it does work. There will always be the flagship buildings, the most sustainable buildings that whoever is building them or designing them is advertising them the best in class, of course. But if you want to move the bulk, you need to have certification. The Passive House, this is the German system which really concentrates on energy performance. So the idea is that this building, and it doesn't have to be a house, it sounds like a house, it can be anything, has very low energy demand. And this is achieved quite simply by super insulating the building. So you've got insulation which really wraps around, somebody said, like a duvet around the building, and it's much thicker and much stronger than what you normally have in a building. So if the insulation goes from 150 millimeters, typically to 300 millimeters, and going underneath the building as well, which is very unusual. Looking at the windows, they have to have triple glazing, so you don't have a loss of energy through windows glazing. You also need to model correctly and include in the calculation all thermal bridging. So first you need to try and avoid them, of course, and this is why timber is quite popular for passive houses, because timber functions as a little bit of an insulator, at least in comparison with metal. But if you do have them, you will have them, then you have to include it very precisely in the calculation. Also the air tightness, so air changes. In a concrete building you will achieve about 2, this is 0.6, so it's a concrete building by definition, if it's in situ, it's going to be sealed box, it's going to doesn't achieve it in 3 years. And last but not least is your MVHR. It doesn't have to be mechanical ventilation with heat recovery, it doesn't have to be mechanical, but you need the heat recovery, that is the key thing. So before you chuck out all the warm air out in the cold, you grab all the heat back and reintroduce it in the building. Of course, they have the very strict rules about how this is assessed, how the building is built. This really increases the requirements on site especially. If you want to achieve, for example, air guidance like this, there is no room for error at all. So the QA, the principles of building such a building are completely different than your standard round-the-mill house. So it's wonderful. You've got a very comfortable building. You have requirements for thermal comfort, for lighting levels, and things like that. So you really like to use this building. It has low energy requirements, but it's not really a sustainable building, in my view. It could be a bit controversial, but it's missing quite a lot. misses all that. So it misses what you're making it from. So you can buy your timber from Brazilian forests and knock down the last species of the planet and build your building. If it complies with the energy requirements, it's fine, it's passive house. You can pollute the environment, you can knock down forest and build it instead. It's still a passive house, but all the other impacts that you have really not discussed. So what we do in cases where we want to build a passive house, we add all the categories back and include them in our projects regardless. So we had the first passive house in London, for example. We had the requirement to build it green. I said, okay, well, no, we'll build it in passive house, and we'll add everything that passive house misses. So in comparison with green, very good, which didn't really have many energy requirements. This is a very efficient, very comfortable building, plus it has everything else that would have been neglected normally in a passive house. Okay, so looking at regulations again, this is where we're getting at. So zero carbon definition. The domestic buildings in UK have to be theoretically zero carbon from next year, 2016, and non-domestic buildings will have to be zero carbon from 2019. In EU, we have nearly zero energy buildings as well coming up, which is slightly different definition. One of the problems is the zero carbon definition is quite unclear in the UK. So what it means up to, what do we know? So it first means you need to have a very efficient fabric, very efficient shape of the building. So you orient it right to have all the heat it should gain, but not too much. So the cooling requirements don't go too far up. So for offices, for example, it's much more important to shade the building rather than to get as much as light as possible. You have good insulation, so thinking about passive house, all those measures that they have, the airtightness, the triple glazed windows. This is the elemental efficiency. Okay? So your basic box. And of course, thinking about it, one of the things is that the more complicated the shape you get, so more loss you have from the facade. So yes, the box is the most efficient shape, and more creative you get, the more problems you get. Next thing is the baseline energy, so what you feed the building, how you run it, your ventilation, your heating, your lighting, things like that. So these systems need to be as efficient as possible. Your LED lighting, CHP plants, things like that. And then you try and mitigate as much as you can on site. So you put your low zero carbon technology on site. You put PVs or use ground source or air source, or maybe even have a windmill or something like that, to try and produce as much energy as possible in a green way on site. But of course, especially in London, for example, this is not quite possible. So in that case, you've got allowable solutions. Now this is the part we don't really know about. How it's going to be calculated, how it's going to be dealt with, we don't know. The government is yet to produce or publicize the rules on this. What our allowable solution means that, okay, you've got some carbon that you're using up on your site, you're not able to offset it on the site, so you have to do it somewhere else. You have to invest in a field of PVs or windmills, or wind turbines, or you invest in a carbon reduction scheme, or in something that's going to reduce the energy consumption somewhere else. But how it's going to calculate, how much you need to pay, you don't know. And that is for regulated energy, so that is for your basic stuff that runs the building. So again, lighting, cooling, heating, things like that. But there's also the unregulated energy, which is everything you plug in. Your computers, your projectors, the washing machine, everything else. And that bit actually is not that small. And I'll get back to that, but this is the problem really that we get in terms of delivering the performing buildings, the unregulated energy especially. the rules that we got from 2016 to 2019 are zero carbon, not true zero carbon, so only regulated energy needs to be addressed. Another thing that's really important is doing things in the right time. So timing in terms of sustainability is crucial. And this has been picked up by various bodies. Has anybody seen this? This is BIM small buildings. It's called McLeany's Curve. McLeany is an architect, and he sort of produced this really to illustrate how important it is to use BIM early on, to sort of try and move all the decisions as early as possible. It's common sense. The sooner you make your decision determining design changes, the less it's going to cost. And believe me, this is absolute truth. The longer we wait with our projects, we want to implement any changes, it costs more. And sometimes there is just a cut-off point to a path to it. Well, actually, it's not that new. This is from 1976, from a paper. It's the same thing, it's the same curve without funky animation. And it means the same, the longer you wait, the worse you're off. It goes for everything. So what has been done about this? This is RABA's plan of work. This is the Bible that we use for our projects, for managing our projects. Is anybody unfamiliar with this? No, good. What you've got in there are sustainability checkpoints, meaning what you need to do in each stage of the project. Okay, we really use this. That has been then translated into, for example, in Green 2014, you've got, again, linked to REBA stages, certain things you need to do, otherwise the red means you're too late. So how do you address this? Very early on, you've got some concept design, then you've got the energy model, and you do the carbon analysis if you do it at all, then you do cost analysis, and the time passes. You do the life cycle costing if you do it, you get some results, and you figure out, oh, actually, we need to change something in the design, but the time has passed and we don't have time anymore. And this is the real problem we have now in visibility stages. So what we've been working on with a number of consultants and engineers is a tool that puts it all together. So you've got full assessment in one point of time, in very early as well. So it says design here, it's really concept design. Okay. So what it does, this is how it looks like. You can also import a SketchUp models. It does your life cycle cost, it does your embodied carbon and operational carbon. And it's really meant for optioneering. So you have an idea of how the building might perform if you change certain things. Of course, this is not a compliance tool. You can't get your Partel compliance through this. This is very early on. Design level is this, or a SketchUp model. So of course you're going to have errors. But the idea is that you have a direction, something to give you an indication of what is the best solution for your project. The main point here is that you can produce all of these results, and I think I've got 10 options in here, in about 10 minutes. Of course, setting them up takes a bit longer, but producing the results, the scatter chart, I'm not sure if it's showing there, takes about 10, 15 minutes. So it's really, really fast. Our involvement there was mostly on certification, being one of the things that we do, but the tool itself has been developed by BDSB Chapman, Sweet Group, Green Space Life Programming, and Architect, the architects. What they've done really, they've done templates. So you apply a template to any of these, and change certain things in terms of the sizes and the quantities of things, but the templates really tell you what happens in each situation. It works really well. So that's the feasibility stage, that's the analysis stage. That gives you an idea where you need to go. But you need to keep in mind everything else that needs to happen. So this is the BIM building information model chart, and I'm sure that many of you have seen it many times. And I really want to bring this home that once the building design, you need to think about construction, especially demolition, trying to reduce the waste. We're trying to reduce the carbon buried in all the waste from out buildings. And that then gets translated to one of the wastes that we can try and reduce are the errors. So what we do is translate the BIM model into Synchro to try out how the building is going to actually build the site and try out all the phases and make sure that everything works right. I'm not a BIM person, but we've already seen quite a lot of benefits, and it's quite possibly the future. The good thing about Rapier is it actually talks to downstream BIM tools, so you can take the model and put it in the ArchiCAD, you can put it in task or planetary modeling and get the results from that. Performance gap, again, is something that I'm sure many of you heard about, and I mentioned that when I was explaining the pyramid. We have a problem, and the buildings don't actually perform as well as we said they're going to. And this is an industry problem, industry-wide. This is from carbon buzz. So where it's coming from, this is what you would model in Partel energy modeling. So we think about normally about regulated energy. There are some assumptions about unregulated energy, but they're not particularly precise. And the problem is that you get all of this. You get building not being used as it was intended in the model, but it could be the model's problem or the building's problem. And you also have the inefficiency, which also include errors in the build and errors in the maintenance. Okay. So all of this can mount up to more than what the building was twice sometimes than the building was supposed to use energy. It's quite a problem. The solution has been proposed by Bisria is a process called soft landings. So going back, these inefficiencies, this extra occupancy, one of the things why they happen is because we didn't design the building for the actual use and maintenance. And this is because, going back to my pets, because people worked in the silos. They worked in the little boxes and didn't talk to the actual users and the actual facility managers, and the actual contractors even, that are going to build this building. Okay? So you got super complicated controls, so people don't know how to deal with, or super complicated plans that managers don't know how to maintain, or they haven't been trained. That's one of the things that you need to involve the users, contractors, and FM in the early stages of the consultation, and then review the design periodically. When the building gets built, but one of the key points is the pre-handover process. Again, making sure that all the testing is done right, but even more importantly, that facilities managers know what to do with the building and the users know what to do with the building. So you don't, as a contractor, hand over a key and ride off in the sunset. You actually hand over the building. This is quite a period of time. It's not just 1 month, it actually extends to a year or 2 years, where you're present on site to begin with, and then go back and help, and reassess the building, and maybe recommission the building. Definitely recommission seasonally, but even a year after, it could be necessary to recommission. This is soft landings has been adopted by the government, so for all central government projects, it's going to be mandatory from next year. So together with BIM level 2, and this is the information exchanges there, this relates to BIM and soft landings, because they come together. All central government projects will require this, and I have a feeling that local governments are going to pick up on this, and clients as well. Private clients. It's very important. So a couple of, not only 2 projects here, I won't bore you too much. The first one is the University of Hertfordshire. We are just finishing, no, actually we finished phase 1, and the Energy Centre is finishing very soon. Phase 2 is on site, and phase 3 is planned for next year. This is student accommodation, including the student hub, which is there. And why is it interesting, especially for this audience, is it's true zero carbon. So this does include the unregulated energy. Okay, we had to be very careful about how we designed and built and going to maintain this project. And the reason for this is that we are bound contractually to deliver a performing building. So ULiving, this is a consortia of designers, contractors, and facilities managers, have to deliver student accommodation is going to be true zero carbon by contract. So we had to really very carefully design our buildings. So all the M&E engineering is went into there, especially the unregulated energy. We have to really map out carefully to make sure that it works, so that we can guarantee this. And in my view, and this is something that we are really working on as a company, this guarantee of performance from your design and contractors, FM team, preferably they're all together, bound in a contract, is really something that's going to as well deliver a performance gap. The motivation is there in the contract. So what the building does, it's biomass. I know I've talked a lot about biomass, but it's not all bad. There's quite a lot of biomass around the Western Capricorn, so you don't have much of a transport impact, and it is a waste material. It gets burnt, but it's not directly used like that. From the burn, synthetic gas is extracted, cooled, and then again combusted in an engine, which is specially designed for this. So it's a CHP plant, and it will recover. It's combined heat and power plant. It will recover extra heat and convert it into power, into electricity. Okay. And we made sure that one of the things about CHP plants is that you don't want them to turn off and on, and I'm sure you know about this. So we made sure that there's enough load at all times to make this really efficient system. And all the extra power is then exported to the network. Now, I said that true zero carbon is achieved on this project. It has been achieved without any low zero carbon technologies. Solely the first two steps, so elemental and plant efficiency. There's no field of PVs producing green energy. It's just simply efficient design. So it is possible. And of course, it's BREEAM outstanding. It got quite a lot of innovation credits for the energy, for the Center for the design of this energy performance, if you like. Actually, if you read the BREEAM manual, strictly speaking, you shouldn't get these credits, because BRE didn't want projects to be, or buildings to be designed as power plants and get credits there. But actually the efficiencies of this project are what drives this true zero carbon. So we got a special 5% for this particular project, for this particular solution, as a particular innovation. They recognize that it's not a power plant, it's just truly efficient system. And then there is Challenger. This is our head office, and there's a little video which will explain a bit better, head office in France. It will explain a little bit better what we've done there. It has achieved BREEAM outstanding, LEED Platinum, and HQE, it's French scheme, equivalent to BREEAM LEED. Excellent, so outstanding as well. Top in all categories. It has a field of PVs, but this is because this is an existing building, so it's a refurbishment project, and we needed to do quite a lot of reduced energy consumption. It was built in the era when energy was not an issue. So, here goes.
Challenger opened in 1988. The site, which was designed on the initiative of Francis Bouygues, was at the forefront of technology and already demonstrated the group's capacity for innovation. In 2008, an ambitious renovation project was launched that did not necessitate closing the offices. Its aim was to return Challenger to its role as a showcase for our expertise. In line with the values of Bouygues Construction, the project is aiming for a triple environmental certification: HQE, LEED and BREEAM. Three principles have guided the renovation of Challenger: improving energy efficiency, producing green energy, enhancing staff comfort. The main challenge of an approach aimed at sustainable renovation was reducing energy consumption. An audit of Challenger's thermal efficiency was therefore carried out. Two avenues for improvement were identified as a result: improving the insulation of walls and terraces, replacing the existing facade with a naturally ventilated double-skin wall. Managing water consumption was also a major concern. A phytopurification facility allows the 100% natural treatment of waste and rainwater without discharge into the public network. Water consumption has been reduced by almost 60% by reusing wastewater on site. Natural resources are also used to produce a proportion of the site's energy requirements. 75 boreholes and a geothermal doublet in the groundwater table provide controlled heating for buildings. 21,500 square meters of photovoltaic panels provide almost 2,000 megawatt-hours of electricity per year, which is used directly in the running of Challenger. The installation of 420 square meters of thermal solar panels produces half the domestic hot water requirements for the staff restaurant and gymnasium. To optimize the use of all this equipment, a cockpit was created. It is a veritable control tower into which all information is fed. The cockpit also has a hypervision area for the remote management of buildings operated by group subsidiary Exprim, which specializes in facility management. The renovation of Challenger also provided an opportunity to improve staff working conditions. Particular attention has been paid to visual, acoustic and olfactory comfort in the office space. The number of meeting rooms has been increased by 50% and they're equipped with flat screens, video projectors or video conferencing systems. 111 mini-meeting rooms were also created in the open-plan office areas so that discussions can take place in complete confidentiality. Challenger boasts outstanding performance levels. Primary energy consumption has reduced tenfold, falling from 310 to 31 kilowatt-hours per square meter each year. Water consumption has been reduced by 60%. Almost 2,000 megawatt-hours of photovoltaic energy is produced each year. Challenger's renovation thus provides an opportunity for Bouygues Construction to establish itself as a major player in sustainable renovation, playing its part in the creation of a better living and working environment for all.
Look at some questions.
Thank you very much, Sasha. Floor is open to questions if you have some.
Thank you very much for the talk, Clive Burke from Cranfield University. Does your company build any glass and steel towers? If so, what is the expected lifetime of them? What advice are you able to give in terms of other than don't? What can you say to the people who build the towers about sustainability and the likelihood of actually ever achieving something useful?
That is a quite controversial question. The towers, yeah, there is quite a big debate about whether they're sustainable or not. Again, it's not a black and white issue. Yes, they have their impacts, but of course they also provide greater density and population for use, which is quite an issue considering that we are running out of agricultural land. So again, thinking about social, environmental, and economic issues. Is it better to build out the green belt, or is it better to put a tower here in London? Depends. And in that sense, I can't say that they are unsustainable in every situation. There's quite a clear requirement for more and more space for housing, for work, for people that are multiplying exponentially. Where are you going to fit them? free to do what we did in the US, expand our cities horizontally, and then you have all the impacts of transport and to drive everywhere and impacts of that. Or you have a building which has its own impacts in a different way. In a sense, what you need to do is, in each particular situation, try and assess what is the best way. But this is on a neighborhood level. You need to think about a city level. Is it better to build a new city, which is going to be somewhere else? You have the transport issues, all the new infrastructure issues, making people want to go there. Mazda City, as far as I know, has researchers in there and people who are paid to live there. So we built this wonderful sustainable city, but nobody is there. But, how much would it cover went into that, and energy and time and everything else. For me, in London, we see situations such as that. Yes, tall buildings are sustainable. Looking at the overall picture, looking at about all the needs that you have and where you need to put them, yes, it makes sense. And again, trying to find a balance between the three: social, environmental, and economic. Somewhere else, in rural areas, of course, building a huge tower does not make sense. In terms of life cycle, life cycle assessments normally stop at 60 years. The official things that you will do for BREEAM and certifications such as that. But of course, we know buildings live longer than that. In which case, then we're going to do a more maintenance routine, and then it makes sense. I would suggest that we need to do longer life cycle assessments.
Stephen Preble from Kingston University. I was quite interested in what you said about the performance gap, and you began to talk a bit about the use of soft landings.
Yes.
And you also talked a bit about the project in Hertfordshire University where you are claiming to have dealt with regulated emissions, which are unregulated and therefore sort of unquantifiable. I'm quite interested to know how you did that, but the key question I have is to what extent are you actually going into completed schemes and quantifying and collecting information and data to ascertain how big that gap is, how much real post-occupancy evaluation are you doing?
Okay. Hertfordshire, we actually did soft landings. We didn't call it soft landings, but we did proper soft landings. By definition, part of your living is a facilities manager. So we have them on board all the time, feeding that information. We development, who's the development arm, and we construction, who's the construction arm. So you sort of have this bit, and then of course the clients and students involved in the process very heavily. Yes, unregulated energy is a little bit of an unknown, but you can have a pretty educated guess, not using the standard tools and standard templates, but actually looking into how the students live in the existing accommodation, what are their patterns of movement, when are they in the dormitories, when they're actually in the lectures, what sort of equipment they're using. So we did very, very thorough analysis of that to make sure that our unregulated unknown is less than unknown. In terms of, so for this particular project, we'll monitor the performance and be present there in the next 50 years. For other projects, it depends whether we allow it or not. So some clients want us to hand over and leave. They don't want to publish their DECs, and they don't want us to know what they're doing. So in these cases, we can't. Wherever, especially in passive house buildings, we have done the post-occupancy evaluation. We have 4 schools now, and schools especially are more amenable to this collaboration, monitoring the performance, going back, engaging with the students and the pupils. This works very well. So we've done the analysis, and they do actually perform quite nearly. There's always a performance gap, even in passive house buildings. And it's simply because people For example, in one of the schools we had an issue with it didn't quite work out well. We didn't quite understand what's going on. We tested it again to check the commissioning. Everything was fine. It actually turned out that in passive houses you can't do the sunlight. This is in Birmingham, so you want a little bit more because it's cold. And the problem was that the arts teacher was using the windows as a display case, so the light wasn't coming through. You didn't get all the heat you needed, so the molding was knocked out. It's as simple as that. Very often, or in Passive House conference last year, they had done an analysis of, it's not our project, of the Passive House development. They went back to take a look at how it's performing. And of course, in relation to normal buildings, the performance gap is small, but there are some that really went out, the average in the sun was really that bad. And this is because people left the windows open and the doors open, they simply not using the building properly. Or turned off the MVHR. And maybe they turned it off because it was placed next to their bedroom and they couldn't sleep. It's quite noisy, so that's a bad design. Or they simply don't want that, they want to open the windows, they don't understand how the building works. So there's quite a lot of the initial stages of the design, and that part, understanding the client and what they want, how they want to use the building is really important. And in some cases, we develop projects where we are the developer and the contractor, but yet to really start from zero, from scratch. And we usually have the client on board as well. There's quite a lot of projects where we get in stage 4, so technical design, almost finished. We can do a little bit and then build it to the best of our ability and commission and handover. But initial stages are beyond our reach. So those projects are more complicated, I would suggest, especially for the other equipment energy.
Great presentation. Thanks very much indeed. John Saltmarsh and Department of Energy and Climate Change. Bit of an unfair question, but 80% of the buildings that we're going to have in 2050 have already been built. Have you got any advice on what we do with those?
Refurbishment, yes. We do quite a lot of refurbishment projects, actually. And one of the things that I've sort of presented mostly on new, actually all of it is a new build. There are tools, there is refurbishment, for example, that deals with this. And I'm going to unfairly criticize Green Deal, which didn't quite work out. One of the mentions of zero carbon hard, carbon to zero hard, was that allowable solutions might involve investing in green deal schemes. And I thought that could be quite interesting, quite a lot of big developments to actually go out and refurbish somebody's home to avoid their carbon emissions. We need to refurbish money. There's not much philosophy about it. And it's actually possible to convert some of these old buildings into passive houses. In my view, it's much better to refurbish than to demolish in almost all cases because of the coded carbon. Even if you rip out everything and leave just the structure, it's still a huge amount of carbon in there, not to mention the time and everybody to build that, and all the impacts that you would have for a site starting off from scratch. So whenever it's possible, it's better to refurbish. Is that the question? Or did I miss it?
No. Simon Foxall from the Architects Practice. In your definitions of sustainability, there's a whole series of categories. None of them actually addressed the life of the building itself, how long it would last, how easy it is to do that refurbishment. There is now a tendency, certainly in this country, to build buildings as tightly as possible to a specification that is about now, and is not about adaptability into the future. I would definitely include adaptability and durability into my definitions of sustainability. They're key to the word itself. Yet somehow they've escaped
They haven't actually. The management category has life cycle costing. So to look, and BRE does want it to be 60 years, not 30 or 40, which is normally down to the sort of certain process. So it does have that. You have the designing for robustness part, which is materials. You've got in the new BREEAM 2014, you've got adaptation to climate change, you've got designing out waste, you've got materials use reduction as well. So you've got this sort of wider subject, and I absolutely agree with you. Again, a building that needs to be knocked down in 10 years because it can't be adapted to new use or the new conditions which are coming actually is not a sustainable building. So yes, and again, thinking about my pets, long-term view, what's going to happen in 20 years' time, how is this building going to be used in 40 years' time, with the changes we know are coming, is crucial. So I absolutely agree with that. It is, you know, I didn't invent the schemes, so they're being updated, and a new update for 2014 does address exactly these issues.
A few things there in context, things like the PCO standard for offices, 18-metre deep plates, relatively shallow floor-to-floor heights, which won't necessarily be adaptable in the future, because the sorts of standards that are still being used extensively. So.
One of the things that it does miss is beauty. And I really, I think you can't build monsters and call it sustainable. And there's a scheme which is, as far as I know, there's only one building in Ireland that's going through that. It's called Living Building Challenge. It's incredibly difficult, which is why it's isn't it? You don't have the choice, you have to do everything. And one of the, quite a lot of it is about being an inspirational, beautiful space. And I think that's incredible. Well, and we try to do that as much as we can. I actually think it should be included in the assessment. The difficulty, of course, is how you assess that. There is no number for beauty. You can't say that it has to be 1969 here. It's not that easy for buildings. Tastes are so very different, which is probably why it was avoided. Still needs to exist somehow. And it was a thinking. What is it called? My brain stopped now. There's a scheme for design. It's not an assessment scheme, but you really sort of consult with the local community and sort of assess, among other things, the study that you do. I don't remember what it is, probably too late.
It's very interesting. Greg Morrison was on the radio last night. It was a largely architectural program, and he was talking about iconic buildings. He maintained that you can't design an iconic building. The building becomes an icon over time because people recognize it as such.
And not every building needs to be iconic. You know, we really love our terraced houses, and they're not so iconic. The area is nice. We want to live in there. I live in a terraced house, I love it. And it's not iconic by any means. There's a gazillion of the same houses all over London, but there sort of we need those as well. Not everything needs to be a statement. And you know, as an architect, ex-architect, one of the things that we didn't learn, taught it actually by professors, that you know, yes, you had projects that you design as an iconic thing, but actually try and design something that fits in as well. You need to create an atmosphere.
Do you have any more questions?
Hunter Anglin, also from Tech. What do you suggest for office buildings or large non-domestic buildings which require air conditioning at the moment? Is there any way that they can be adapted to not require, or do you just have to have very efficient air conditioning for the long term?
Again, it will depend on the situation, how much of natural ventilation you can implement. Can you have chill rooms or not? Can you know, sometimes you have to have air conditioning, but maybe you can have some sort of zero carbon. You know, can put some PVs where you can have into hopefully it will be soon feasible, turn the facade into your energy generator. So you don't, as you will all know, there's two sides of the debate. Do we try to make our buildings as energy efficient as possible? Do we try to make our energy as green as possible? So we don't care how energy efficient buildings are. Of course we should do both. But in some cases you will have an iconic building which is being refurbished so that there's a value to it, like Parliament, for example. It's never going to be energy efficient. But it is, its value is immense. The social value is immense. Of course you're not going to demolish that and build an efficient building. But what you can do is try and offset the carbon footprint of a building like that in various ways, including zero carbon technology. Something else specific, perhaps. Or just generally the whole energy of the country can be cleaner. No problem.
I wanted to ask you a final question, which is why an organisation, a company like Bouygues, would invest in a sustainability team. Is it because you want to move beyond the traditional contractor role of build and walk away and move more into to build, own, operate, lease, whatever the model is?
Well, we're already there because of our different arms. We've got property development arm, contractors arm, and facilities managers arm. We do deliver projects throughout and keep in there. But of course, if you look at just the strict projects where you have a client who's anywhere in a building to be handed over, we still want it to perform. And I can sort of sing all sorts of platitudes, but actually it makes business sense. It really does. In this day and age, delivering a building that's on time and cost, it sort of does what it looks like it should look like, it's a given. Of course we're going to do it. Of course nobody's going to get killed on site. It's a given. You can't advertise that as something special. You need to go further. And this is one of the areas that I feel is extremely important.
Well, we'll all say thank you very much to Sasha.